Okay, so we left off on this. It's tangent -3 over square root of 11, and we put that in our calculator, and we get 0.7353-ish, and that's theta. So if we look at our formula, we have r, it was 2 square roots 5. We have n, it was 2. We have n again, it's 2. So we have the n's. And then now we have the thetas. It's that 0.7353. Okay, so now we're going to plug it all in the formula, this r to the n formula. So instead of r to the n, so we're going to say z to the n equals, instead of r to the n, we're going to have 2 square root 5, because that's my r, to the n power, the n is 2, parentheses cosine n theta, that means 2 times 0.7353 plus I sine n theta, 2 times 0.7353. Okay, now I'm going to do this 2 times 0. So I'm going to take 0.7353 and times by 2, and I get 1.4706 for both of those. And then now I'm going to take cosine of 1.4706. So let me type it in. Cosine 1.4706. And you get 0.1. Okay, so I'll just say 0.1 plus I times, let's do sine of 1.4. Sine of 1.4706, and that's 0.9949-ish. And then I still have this 2 square root 5 squared, but let's figure that out. If I square this 2, it makes 4. If I square a square root, that makes 5. And then 4 times 5 is 20. So now let's multiply the 20 up in it, and then we'll be done. So 20 times 0.1 is, I think it's just 2. And then 20 times 0.9949, let's see, 20 times 0.9949 is 19.898, and this said we're supposed to round to 2 decimal places. So I'm gonna go ahead on this 2, put a 0.00, and then I'm gonna put plus 20 times this decimal was 19.2 decimal places. Instead of 898, I'm gonna put 90i. And that's the answer. Woohoo! Okay, the only thing left to do is finding roots of complex numbers. And to find the roots, we have to use a special formula. It looks like z sub k equals the nth root of r, bracket cosine theta plus 360 times k over n, plus I sine theta plus 360 k over n. And if it tells you it wants the first root, then you plug in a 0 for k. If it says it wants the first and second root, then for the first root you plug in the 0, but the second root you plug in 1. For the third root you plug in 2. For the fourth root you plug in 3, blah, blah, blah. And then when it comes to roots, i's come in pairs. So as in plus minus. So if I have 5i, I'm automatically going to have negative 5i when it comes to the roots. So this says, find the fourth root of 11 plus 11i. So whatever the roots are, I'll have a plus and minus of it. Okay, so let's see here. In this formula, I have z sub k. So for us, we want the fourth roots. Like we want the first, the second, the third, the fourth. So we're going to use k of 0, 1, 2, and then 3. So we're going to have k equals 0, k equals 1, k equals 2, k equals 3, and that makes 1, 2, 3, 4 roots. Okay, so now we know what our k is. Let's figure out what our n is. Our n is whatever root they want us to find. So they want us to find the fourth root. Get it? Because it's like the fourth root of r. So our n is 4. So down at the end. For r, remember r is equal to square root a squared plus b squared. So let's figure out what that is. For 11 plus 11i, a is the 11. That's real. B is the imaginary part. So a equals 11 and b equals 11. Okay, now let's plug that in to get my r. So I'm going to have square root 11 squared plus 11 squared equals, that's like 121 plus 121. I think it's 242. Or another way to write that is 121 times 2. And then 121 breaks into an 11 and 11. And that gives me 11 square root 2. So that's my r. So we have my r. Cosine theta. We don't know what our theta is, but again, I have my k. They're all different. We're going to have to do the problem like 4 different times. I have my n. Over here, I have my k and my n. So I just need to find my theta. Okay, so let's see here. My theta, it should be tan inverse of b over a. Let's see if we've written that somewhere already. Just write that down. Oh, we just did that one when we were talking about exponents of complex numbers. So tan inverse of b over a. It's kind of like tan inverse of y over x. Okay, so this makes tan inverse of my b is 11. My a is 11. So that makes tan inverse of 1. And then I think we can do this from the unit circle. What y divided by x gives you a 1? Well, the square root of 2 over 2 divided by square root of 2 over 2 at 45 degrees and also at 225 degrees. So theta is either 45 degrees or 225 degrees. And we want to use degrees when we're using our calculator. And to figure out which angle it is, we think about where 11 plus 11i is on the graph. That's like 11 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 11 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Anyway, it's up here in quadrant 1. So looking at these two angles, which angle is quadrant 1? 45. So that's my theta. Okay, so now I'm going to use this formula. And I'm going to have to use it 4 times to find each root. Well, hopefully we can just use it 2 times. And then remember that i's come in pairs and just use a plus minus. Okay, so first we're going to find the first root by plugging in k equals 0. So we're going to have z of 0 equals the nth root of r. So the n is 4. The r is 11 square root 2, awkward, bracket, cosine, parentheses, theta, 45 plus 360 times k, 0, all over n, 4, plus I sine, parentheses, theta, 45 degrees, plus 360 times k, we're still using 0, all over n, which is 4. Okay, and then let's see here. Let's figure out what this little sucker is. I'm gonna type in 11 square root 2. I'm just using Desmos because my computer calculator doesn't work. So 11 square root 2. And it's like 15. But then I'm going to take the fourth root. And another way to take the fourth root is to say, like raised to the 1/4 exponent, or even like 0.25 exponent, because 1 divided by 4 is 0.25. So I'm just telling you that because I have to use this funky calculator. But fourth root. So I'm going to take that 15.5555. 15.5563, and I'm gonna raise it to the 1/4 or 0.25 because I don't have a fancy calculator, and I get 1.9859. 1.9859. Okay, good. And then bracket cosine. Let's see, 360 times 0 is 0, plus 45 is 45. 45 divided by 4 is 11.25, plus I sine, this is the same thing, 11.25. Okay, now we're going to figure out what cosine 11.25 and sine 11.25 is. So let me type it in. Cosine 11.25 is 0.2516. 0.2516 plus I, and then sine of 11.25 is, let me type it in. Awkward, negative 0.9678. And that's what's in the brackets. And then I still have this 1.9859 in front. And now I'm going to distribute it, and that should be my first root. So I'm going to multiply this 1.95 times 0.2516, and that makes 0. I'll just say 5 because it's 0.499. So 0.5. And then now I'm going to multiply this negative decimal times this 1.9 in the front. 1.9859 times 0.967. And I should get 1.9, and it's negative. So minus 1.9219, and it has an I on it. Okay, and then it says something about rounding to the 10th. So I'm going to say 0.5 minus 1.9i. So that's my first root. Woo! And then I also have a second root because i's come in pairs. So because I have that 0.5 minus, I'm also going to have 0.5 plus 1.9i. So that's another root. Woo. Okay, to find the other, I don't know which root it is though, sorry about your bad luck. But to find the other roots, we're just gonna have to go back and plug in 1 for k, 2 for k, 3 for k. So right here, we're just gonna change this times 0 to like times 1, times 2, times, but nothing else changes. Like this 1.985, it stays the same in the front.